Welcome to this tutorial on variable types in PowerShell. In this video, we'll explore the different data types available in PowerShell and understand how to work with them effectively. PowerShell supports several fundamental data types that allow you to store and manipulate different kinds of information. We'll cover strings for text data, integers and other numeric types for numbers, arrays for collections of values, and hash tables for storing key-value pairs. Understanding these variable types is essential for writing effective PowerShell scripts and automating tasks efficiently. Let's start with string variables, which are used to store text data. In PowerShell, strings are enclosed in quotes. You can use single quotes for literal strings, where the text is treated exactly as written. For example, $name equals single quote John Doe single quote. You can also use double quotes, which allow variable expansion. This means if you include a variable inside double quotes, PowerShell will replace it with its value. For instance, $greeting equals double quote hello, $name double quote will actually display hello, John Doe. For multi-line strings, you can use the @ sign with double quotes, which allows you to write text across multiple lines while preserving the formatting. Integer variables store whole numbers without decimal points. They're perfect for counting, indexing, and mathematical operations that don't require fractional values. Creating an integer is simple. Just assign a whole number to a variable, like $age equals 25 or $count equals 100. You can perform arithmetic operations on integers using standard operators. For example, $sum equals $age plus 5 will add 5 to the age variable. Similarly, you can multiply, subtract, or divide integers. If you want to explicitly declare a variable as an integer, you can use square bracket int square bracket before the variable name, like square bracket int square bracket $number equals 42. This ensures the variable will always store integer values. Beyond integers, PowerShell supports several other numeric types for different precision needs. The double type is the default for decimal numbers and provides double precision floating point values. For example, $price equals 19.99 automatically creates a double. If you need single precision floating point numbers, you can explicitly declare a float type using square bracket float square bracket. The decimal type offers the highest precision and is ideal for financial calculations where accuracy is critical. You declare it with square bracket decimal square bracket, like square bracket decimal square bracket $amount equals 1234.56789. For very large whole numbers that exceed the integer range, you can use the long type by declaring square bracket long square bracket, which can store much larger integer values than the standard int type. Arrays are collections that allow you to store multiple values in a single variable. They're incredibly useful when you need to work with lists of items. To create an array in PowerShell, you use the @ sign followed by parentheses containing comma-separated values. For example, $colors equals @ sign open parenthesis, single quote red single quote comma single quote green single quote comma single quote blue single quote close parenthesis creates an array of 3 color names. Arrays in PowerShell are flexible and can hold mixed data types. You can store strings, numbers, and even Boolean values in the same array, like $mixed equals @ sign open parenthesis, single quote John single quote comma 25 comma 19.99 comma $true close parenthesis. To access individual elements, you use zero-based indexing with square brackets. The first element is at index 0, so $first color equals $colors square bracket 0 square bracket retrieves red. Once you have an array, you can perform various operations on it. To add items to an existing array, use the plus equals operator, like $fruits plus equals single quote apple single quote, which appends apple to the fruits array. You can get the number of items in an array using the count property. $count equals $fruits.count returns the total number of elements. Looping through arrays is straightforward with the for each statement. The syntax is for each open parenthesis $item in $fruits close parenthesis open brace right host $item close brace. This loops through each element in the fruits array and displays it. The for each loop is one of the most common ways to process array data in PowerShell, allowing you to perform operations on each item individually. Hashtables are powerful data structures that store information as key-value pairs. They're perfect for organizing related data in a structured way. To create a hashtable, you use the @ sign followed by curly braces containing key-value pairs. For example, $user equals @ open brace name equals single quote Alice single quote, age equals 30, city equals single quote Seattle single quote close brace creates a hashtable with 3 properties. Each key is associated with a value, making it easy to store and retrieve structured information. You can access values in 2 ways, using square bracket notation with the key name in quotes, like $username equals $user square bracket single quote name single quote square bracket, or using dot notation, like $userAge equals $user.age. Both methods retrieve the same value, but dot notation is often more convenient and readable. Hashtables offer several methods for manipulating data. To add a new key-value pair to an existing hashtable, use the add method, $user.add open parenthesis single quote email single quote comma single quote Alice at example.com single quote close parenthesis. This adds an email key with the corresponding value. Updating existing values is simple using dot notation. $user.age equals 31 changes the age value to 31. If you need to remove a key-value pair, use the remove method. $user.remove open parenthesis, single quote city single quote close parenthesis, deletes the city key and its value from the hashtable. You can also retrieve all keys using the keys property. $keys equals $user.keys returns a collection of all keys in the hashtable. This is useful when you need to iterate through all the keys or check what properties are available in your hashtable.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.